Hello students, today we will discuss the velocity time graph. Okay, so this is the second part of this to be this chapter, velocity versus time. Okay, this one we will read today. This is very important and repeatedly question is repeatedly asked from here. Okay, so we try to understand this one. This is very important, I am telling you. So you know that one, this velocity term, we all know that. What is that? This is actually displacement by time. This is the formula. It depends on two factors. One is displacement and second one is on time. Okay, these are the two things. Displacement, we all know that. Suppose a body start from here, one directional motion, maybe I'm just taking here because one dimensional linear motion this chapter we are reading. So the body is moving in this way. Okay, maybe 10 meter forward it moved, so definitely you have to tell that its displacement is plus 10 meter. Suppose it will move in this side. Okay, and it will move just cross this point, this a point, maybe by 5 meters. So what will be the displacement? Minus 5 meter. Okay, we all know that. And after some time, after going to this position and again reaches to this position, if it will stop, then the displacement will be zero here. So displacement, the main thing I just want to say, that displacement can be positive, it can be negative also, and it can be zero also. So as displacement can be positive, negative or zero, so you all can conclude that velocity can also be like this. No, it can be positive, it can be negative also, it can be zero also. Okay, so from velocity time graph, when we will calculate that negative value, you can also able to get negative acceleration, you can also able to get, because acceleration is depends on the change in velocity by time. So these are the things. So main thing is that from this chapter, what is the main thing we can calculate from here? Here we all know that velocity of a body is actually what? This is actually displacement by time. So to think you, the first thing you can calculate from velocity versus time graph is this one. How can you calculate? Displacement is equal to, you can write down, that is equal to v into t, velocity into time. So from this formula we can calculate. I am giving you one example, it will be clear to you. Suppose one graph, one velocity time graph I have just I'm just drawing here. One, this side y axis always will give you the velocity and this side will be time. Okay, maybe this one in meter per second and this one maybe in second. Okay, suppose one, this type of graph is given to you. Okay, this one is 0, that means initial position, this one is 1, and this one may be 10 is given to you. Okay, so from here we can easily see this whole diagram is one type of rectangle. Okay, and this side will give you what? This side will give you the velocity. Same, this side will also give you the velocity, this side will give you the time, and this side will give you the time. Okay, maybe you are understanding this one, because this is a rectangle, these two sides are same, these two sides are also same. So if you just use this formula, velocity displacement is equal to velocity into time, then what you can calculate? First of all, you can see how much velocity is there. Velocity is this one, this is the velocity. So this is 0, this is 10. So velocity is equal to 10 meter per second is given here, and time is equal to how much? Time is equal to, definitely 0 to 1 second it took the time, so definitely that is 1 second. So if you want to calculate the displacement from here, this graph, it will definitely give you 10 into 1, that means 10 meter will be the answer from this graph. So basically what we have calculated, we are not calculating the area. What is the what do you think? Definitely we have calculated the area of this rectangle. Length into breadth, we all know that that is the area of a rectangle. We have just done the same. This is the length, that is the time. This is the breadth, that means this is the velocity. So velocity into time we have just calculated here, same thing we have already calculated, you see this one. So basically when we will calculate the displacement of a body, we have to calculate the area of the diagram encloses. Okay, that is the main thing. One more example I am giving you, then it will be clear to you. Suppose this type of diagram, that rectangular diagram, is not given to you. Same thing, time in second in the x axis, velocity in meter per second along the y-axis. Suppose this type of graph is given to you. Okay, this is the 0 position. Maybe this one is the height of the triangle, and this one may be 2. Okay, and this one is given to you maybe 10. Okay, so 10 means 10 meter per second velocity is given to you. Now thing is that what we are going to calculate here, we are trying to find out the displacement of the body. So we already just concluded that we have to find out the area of this triangle. Okay, if we are able to calculate the area of this triangle, then we can able to calculate the displacement of this one also. What is the area of the triangle? Area of the triangle is equal to area of the triangle, that's why AT I have written here. We all know that that is equal to half into base into height. That is the general formula, we have already learned that one. This is the base. Okay, this is the base portion, this is B, and this one is the height of the triangle. Okay, so what is the base here? How much base we are getting? 2. Base we are getting here 2, and height we are getting how much? This one is the height, that means this is the height, so that means this is equal to 10. So if you calculate that one, then you will get 10. What is that? We have already concluded that area of the enclosed figure will give you the displacement of the body. So definitely the displacement of the body is equal to 10 meter. Okay, suppose you are having a different type of diagram, is a complicated type of diagram maybe is given to you. Suppose the body has gone this much in this way, then it has covered this amount of distance, then it will come back. Okay, suppose this diagram is given to you, this is 0, this side definitely velocity, this side definitely time. So if you want to calculate the area of the displacement of this, then you have to calculate the area of that one, we have to calculate the area of that. How can you calculate? Two possible ways are there. First of all, if you conclude this one a parallelogram, then one formula is that half into sum of the parallel sides into height. This is one formula to calculate the area. Second formula, individually you conclude that. Just I am just marking this one line I have drawn. Okay, so 0 may be A, this one is B, this one is C, this one is D, and this one may be E. Okay, that is given to you. So three things we are getting. One triangle, we have to calculate the area of this triangle. Okay, one rectangle, this area we have we have to calculate area of the rectangle, and another triangle is also given, that triangle area we have to also calculate. So if you add these all area, this one and this one, this plus this plus this, if you add these three things, you are definitely able to get the displacement of this body. Okay, so this is the actual thing, this is the actual idea we have to calculate. Second thing is that from this type of diagram, okay, can you able to get any more type of thing, can you able to calculate? Definitely we can calculate the acceleration of a body. Acceleration we can also calculate from a velocity time graph. Suppose one diagram I'm just giving you that triangular type of diagram we are just drawing here. Okay, this is one triangular type of diagram. So acceleration means what? That is actually change in velocity divided by time taken. Okay, this is not actually velocity by time, this is a change in velocity by time. Okay, suppose I am giving you this one is 0, this one I am just maybe marking 10, this one is 2, maybe I am just marking, this is the height of the triangle. Okay, so basically what we have to calculate, we have to calculate acceleration is equal to v change divided by time taken. Okay, this one we have to calculate from here. What is the v change? Velocity initially is 0. Okay, final velocity is how much? 10 meter per second. So change in velocity is equal to final velocity, that means 10, minus initial velocity is equal to 0. So that means 10 meter per second will be the change in velocity. Okay, time taken is equal to how much? 0 started from 0, definitely it will just initial position, and time taken is 2 seconds. So 2 seconds is the time taken. So acceleration of the body will be how much? That will be 10, that means change in velocity divided by the time taken, that means 5. What will be the unit? Meter per second square will be the unit of the acceleration from this graph. Maybe you understood. Okay, so basically what we have calculated, we have calculated the slope of the curve. Okay, isn't it? This is slope we have already noticed, already calculated in displacement time graph. So definitely this is the slope. That means slope means this one divided by this one. If you do the same, then you will get the same also. Okay, this one is how much? This one is 10, and this one will be how much? From here, suppose if you calculate the whole, actually the slope, if you calculate, this one is the height and this one is the base, so divided by 2, so definitely you will get the same here. Okay, this one, that means not this one, this total one. Okay, so as you calculated the same thing, or if you calculate individually, then you have to add this one. Okay, so total I have calculated, so this one. But suppose one different type of graph is given to you. Suppose this type of graph, velocity here, time here. Okay, this type of graph is given to you. Suppose this is 0, this may be 5 I have taken, this one is 2, this one is second, this one in meter per second. Okay, now we are going to calculate the acceleration of this one. Acceleration means what? Acceleration, we have already learned that one, that change in velocity divided by the time taken. Now if you see that body has just achieved the velocity here, how much? 5. Then within these 2 points, this one and this one, within, suppose if you mark this one A and this one B, within A and B point, what is the velocity? How much velocity is there? Only the same velocity we are getting, because this graph is representing you the constant velocity graph, or uniform velocity graph. You can also, not uniform, constant velocity graph, you can tell that one. Because at a point, suppose if you consider va is equal to 5 meter per second, that means at a point velocity is how much? This one. Okay, this one. And at vb point, okay, the velocity will be how much? Same again. So change in velocity means how much? vb minus va is equal to 5 minus 5, that is equal to 0. So acceleration will also be 0. So whenever you will get this type of graph, that means this line will be parallel to the time axis, then you will definitely get the acceleration is equal to 0. So this is the basic thing. This is the first part of this. Next, in the next video, I will just tell you the applications of this one. So please try to just remember this one. This velocity time graph is very important. I am telling repeatedly this one. Okay, so thank you.